This topic is the in-vehicle IVR information discrete solutions. The product list comes from a car battery. The power will be protected by the protection includes transient protection, reverse polarity protection, and this 12 volt will be boosted to about 27 to 40 volt according to your LED string pieces for a backlight LED display. And the 12 volt will be bucked to the 5 volt. It could provide 5 volt and regulate to 1.1, 1.8 or 3.3 for the micron bias. And another portion for the 5 volt will supply audio amplifiers, and for the 5 volt, if it needed, this 3.3 will be boosted by the regulators to supply the 5 volt to the CAN bus transceivers. The 5 volt also, if the high-end vehicles, it will need an ecosystem for the security concerns. So, to consider if this battery is disconnected, it will need to integrate the ion batteries to the backup. So it will need O-ring power pass demand. So the 5 volt will regulate to 3.3 for GMS modules, 1.8 for the micron, 5 volt for the GPS module, 9 volt for audio amplifiers. Because there is integrated the ion battery, so it will need a battery protectors and a gas gauge to charge this ion battery. And of course, it has the external USB 3.3 protocol and USB 3.0 protocol and USB Type-C and the Bluetooth protocol. As for the product diagram, the colorful is what DSD discrete can supply. As for the transient protection, reverse polarity portions like these portions, it has many solutions like this. The first, if the circuit is typically used for low current application, if the current is less than 3 ampere, it can advantages include simply and low power consumption loss. So there is the reverse polarity diodes here and the transient protection TVS here. As for the reverse polarity diode, I would recommend is the Schottky 60 volt 3 ampere. As for TVS, if you have low down consumption, we recommend the 6.6 kW 25 volt working voltages. As for the lighting surge protections, 600 watt unidirectional 26 volts demand. If we want to improve power efficiency, we can put a PMOS to replace our reverse polarity diode here. The MOSFET is PMOS is the spec with 30 volts and 40 milliohms. As the MOSFET, one of our customers, it used 40 volt and no G level. As there is the DINA die to protect gate and source pins. The breakdown voltage 80 volts. If you want to do the power efficiency further, we can use the NMOS here as the TVS, we can use the 600 volt bidirectional working point 26 volts. Our solutions like these products, one of customers used 3K watts, and our products like this, the polarity protection for this MOSFET is we need the N channel, and the voltage is 40 volt, RDS on 3.4 milliampere ohm. As for the buck regulator and boost regulators, the buck regulators comes from the car battery flow regulator to step down to 5 volts, and it is the integrated switch MOSFET internal, and this buck regulator, the freewheel diodes, we can recommend the Schottky diode 40 volt 5 ampere pumper like this. One of customer and use the 40 volt to 3 ampere, and we also have a recommendation products like this as the booster regulators for this state of converter integrated MOSFET. And we can provide the Schottky diode here. It is SOD123 package 30 volt 0.35 ampere. As for boost LED drivers, it can supply for display no backlight. The first input that's overcurrent by measuring voltage by is the sense resistance connecting the resistance. So there will be a PMOS potential 60 volt 30 ampere, and as for the boost LED drivers MOSFET, it will be used 60 volt 23 milliohm. As for the booster diode, the Schottky 100 volt 5 amperes, and recommend parameter like this. And one of the customers we use the MOSFET is the 40 volt 10 milliohm, and we have related parameters. As this Schottky diode, we also have related parameters like this. The ecosystem for the O-ring ring power pass. If you use a discrete to lay out this, there is a fiber comes from power car battery and will step down to 5 volt, and there is an internal backup battery. Iron battery is about 4.52 volt. If this 5 volt and the iron battery will be supplied to the comparator here, if this 5 volt is bigger than the backup batteries, the comparator will provide low voltages. It will make this PMOSFET to turn on. So this fiber comes from car battery pass through the O-ring to supply the following ecosystems. If the backup of the internal battery, the iron battery, is voltage bigger than 5 volt, the capacitor provides a high voltage level. It will make this PMOS to turn off, so this battery can pass through these O-rings. As for a battery protector and the gas gauge for ecosystems, this IC is controlled The on-off of the MOSFET, familiar charging discharging for the battery. So either receive the signal from the micro. This is the serious signals, and there will be a charge and discharge MOSFET like here. So the battery protector and the gas gauge, we use the 30 volt 9 milliohms. So recommend the primary is this is our 40 volts MOSFET. As to protect the series signals, you can use the ESD or Zeners station like this. As LDO to supply microbios, we have some recommendation for the output voltage 3.3 volt. Even one of the customers need quite some voltage, be that 20 microampere, their pin now. As the CAN bus ESD production comes, if we consider the CAN bus high and the CAN bus low, the switching voltages for the minus 25 volt and the positive 3.3 volt, and we also need to consider the battery voltage 20 volt because the jump start problem to measure the working voltage 24 volt. As for the 8 picofarads, it is a high speed 5 megabits. It's a normal speed 125 kbits. Choose 30 picofarads. The USB 2.0 is a transmit rate 480 megabits per second. His signal rest time 0.6 nanoseconds, so the ESD will need smaller capacity than 40 picofarads. And we also to consider its half translate for the deep data rate 3.3 volt single voltage and the B-bus 5 volt. So we recommend is if you want to protect one port, then is the small package DN 1 liter 6 working with 5 volt 0.4 picofarad. And we have another current solution SOT236 to come to protect it. As for USB 3.0 transmit is faster 5 gigabit per second. The signal rest time is only 0.06 nanosecond. So ESD is the junction capacity need to less than the 1.8 picofarads. So consider the half the plus. As for the compatibility of the two pairs and the full differential signal duplex is a serving voltage 3.3 volt, and we are developing the ESD protection will be this. As for D plus D minus, we use SOT236. USB Type-C it transmit is faster double for USB 3.0 10 gigabit per second. The ESD will need less than 0.5 picofarad for the junction capacitance. And his signal voltage swimming is very similar with the USB 3.0. So we are developing the working voltage 3.3. Junction capacitance only 0.18 picofarad like this. As for Bluetooth, because the structure is very like near field NFC. So his maintainer to the ground where about the switching swing is 80 volts. Your DSD at the default volt has 0.35 picofarads. Okay, thank you.